so upset.
Yeah. So whatever is it, I will
No, what can go like?
not like once in a while he begin peeing at
shows up.
not like peeing by taking pee position, but like just walking and then leaking.
Tieto, actually. Oh, by the way, yes, that's live now. So if you wanna,
Just talking about throwing up.
it's fine. Now everybody will see it.
Seriously?
Well, we promised to go live at 6, so we're even like 4 minutes late.
He's talking about how Ben is throwing up.
Why do you continue still?
Ai niinku siitä on se miinusteli vaikka näin. Siitä tiedossa. Tässä aika
Yes, a lot. What's this?
If you check Tieto for
se mikä haavistus. Joo. Tai siitä tulee mikä se ei voi
somewhere. Алло.
Voitaisiin jonkun verran. Hei. Я просто Кари написал. Niin siinä menee isällä aikaa. Sulla sanoa aikaisemmin, että sä tulet, kun Aleksi jätti just välistä. Se on aina tää mun nyt sieltä tää jostain. Se oli Ruotsissa. Okei.
I didn't bother. It's all in the intro.
Pitäis taisi olla kakkoista. Excelistä vaan database. Okei. Ja toinen näistä käyttöpuheista oli viime tuossa reaktorissa. Voisista pizza.
Is it live? Do you check? Is it live? Yep.
I don't know.
I took it out, yeah. Yeah. Well, you're actually on live stream as well, so. Five people are watching. Let me see if you're in the. Half of you are in the video.
How about you? Sorry. Oh yeah, it's recording. Fine. Yeah. So he's growing quite soon. Forward to
No, big mistake.
اتفاقی که داره طرفداری خیلی آدم خیلی با اون
واقعا سخت الان به مردم بدبخت میشه از همین اساسی که یارو مسئول این حوادث غیر مترقبه برایش مردم حرف شدن دوستاشون زیر آب رفت ولی خوشحالن از این نعمت واقع Like, where is the link? Where's the link?
My Twitter.
Pare, se vai com o pai.
Bem, Я просто...
Aina valita vain nimen.
Дизайн программы, моя часть. Условно, есть между ними я должен какие могут быть то, что я ненавижу, ресурсы.
عوضت دادی؟
هم عوض کردم ولی نامردات حالا نمیدونم من حالا چیز کنم بهشون که عوضش کنم میتونم ادامه بدم یا یه ماه همچنین میگیرم
کنم 2 ماه
2 ماه
80
حالا به اول یارو میاد
حالا باش بگم میرم خوبی 2 ماه هم مثلا ولی مطمئنم هم میتونم بسیاری 2 ماه
مشکل اینه که
اینجا هم داره تغییراتی میکنه یعنی حالت انحصاریش هم داره جدید مثلا خیلی مشکلی که داره قبلا مثلا 4 سال پیش هم فقط
Alright, hello everyone. I guess we can start. So good to see such a good turnout despite us announcing this a little bit late. So I guess first of all, big thanks to Tieto for hosting us once again, and Salar, Andra, and all others who've helped make this happen. Yay! Then a couple of announcements. So I guess the first thing is this is being streamed through YouTube, and I would like to make some sort of a record in terms of the number of views. So we've posted the link to the YouTube video live stream to both Twitter and Facebook. So please do go ahead and like and share and repost those. You can also go in front of the camera and wave to mom and friends if you want. And then the other announcement is that we already have a date for the next event confirmed. It'll be as soon as April 9th, so in, I guess, less than 2 weeks. Yeah, but we are still looking for speakers there, and we are always actually looking for speakers. So if you know someone, or if you yourself want to give a talk, you know, don't hesitate to sort of tell us. I'm gonna have to leave early today, unfortunately, but Emily's gonna be around. Emily, well, everyone knows what Emily looks like. So talk to Emily if you have any questions, but also you can submit your talk proposal either by email or through the website. There's like a tiny propose a talk link that you can barely see, but you can just use Command/Control F to find it on the page. And then all you really need to do is just write the title. You don't need to fill in a description. We can figure all that out. And then we'll get back in touch with you and help you refine that talk proposal and confirm the details. Yeah, Emily will be the one that you should talk to if you have any questions. Although he's lost his voice, so he won't actually be able to answer them, but at least he'll hear you out and nod approvingly. All right, cool. But without further ado, Salar from Tieto is up next with the first talk, and you'll be talking about optimizing web apps using WebAssembly.
Yes.
Awesome.
All right, cheers.
You have to fix it.
I guess so. Maybe.
Yeah. Drop it on.
Mute that. All right, this is amplifying my voice way too much. Hey everyone, I'm Salar. I'm from Tieto. A few practicalities first. So if you come by car, you need to take a password from the reception. Otherwise, you have to leave your car tonight. The second thing is after. No, just leave it here. The second thing is after this event, whatever time it ends, we can go to sauna. There is 2 saunas, ladies and gents, and there's towels and drinks there, but sadly no food. We can order some if you're hungry. And then bathrooms are at the entrance, and coat rack, we have seen, you don't have any coat. But that's it. So if you need to go out and in, please ask somebody from Tieto with the Tieto badges, because the doors are closed after 6. But I guess you're kind of a prisoner here, but that doesn't matter. All right, let's go to the talk then. So as I said, I'm Salar. I'm Salar Kavoli. I'm principal software engineer here at Tieto. And they have told me to tell you that we are hiring. And we are hiring software engineers, solution architects with all skill levels. It doesn't matter if you're a junior developer, senior architect, we're hiring. So please contact me or again, one of the Tieto peeps here, so let's arrange some meeting. But now let's talk about WebAssembly. But for that, we need to know what WebAssembly is. So far, you know that you can write web applications using JavaScript, because since VBScript was distinct, JavaScript is the only language that you can write for web. But that is not true anymore, because you can use any languages, any programming languages that you want to write applications for browsers. Languages like C, C++, Rust, C#, .NET, any programming language that you fancy, you can just use that, write a web application, and how that works I will explain a bit later. But you write your code in your preferred language, and then you compile it to WASM target, and then you add some glue to be able to run it in the browser, some JavaScript glue. Let's say that you want to interact with the page, interact with the DOM, with anything that happens on the page, you need to add some glue so your application is aware of those events. And then you push that to your browser, and then live happily ever after. But where is it useful? For porting, the first thing that happened when WebAssembly came around was porting graphics-heavy games to browsers. So let's say you have a really nice game on your console or PC, but you want to port it to the browsers, or you have an old operating systems like Windows 95 that you want to run in the browser. WebAssembly can be your friends. You can compile your C code to WebAssembly and run it in the browser without any problems. For scientific simulations and compute-intensive calculations, this is weird, which I'm gonna talk about today. For many process-intensive calculations, you cannot really rely on JavaScript all the time, because JavaScript chokes if you put too much on it, for reasons I will explain later. For using the same code in different environments, let's say that you have a mobile application, and in that mobile application you are using React Native for iOS and Android, and you're running the same code in browser and also in Electron for running desktop applications. If you have JavaScript, you might not be able to compile some of that to React Native, because React Native's JavaScript compiler doesn't actually run on V8, so crypto is not available. So you can write your crypto in WebAssembly and compile it to different targets. For Internet of Things, mobile apps, etc., when WebAssembly becomes more popular, it can just be used in more places. But what's wrong with just JavaScript? Why shouldn't we write JavaScript? That's a loaded question, but I'm going to try to explain a bit. Important. So, this is how JavaScript works. Every JavaScript file is a bundle of text. That's the kind of what your program is. It's just text. The browser doesn't know about it. It might be wrong. It might not be downloaded correctly. But once it's downloaded as text, it has to be parsed by the browser. Then it has to be compiled and optimized, then re-optimized, then executed, then the truck comes and takes the garbage out. How WebAssembly compares, these steps are much smaller, which I will explain. So the first part, parsing and decoding. But before we get to that, we need to talk about downloading it again. So as I said, JavaScript is just a text file that you would just download, and the browser has to work on that text file. And that text file, as you know, might be megabytes of text. It might be gzipped, so it's smaller, but still it's a big text bundle. But WebAssembly, in comparison, because it's compiled and optimized already, it's a very, very small bundle. So a JavaScript application that might be, let's say, 500 kilobytes can be in WebAssembly in 30 kilobytes or 20 kilobytes. So the bundle that you download is much smaller. But then you get to parsing and decoding it. In JavaScript, again, your application is text. The browser does not know anything about that. It has to convert that text to AST, abstract syntax tree. And it's a long process. There's a lot of text, there's a lot of minified code there that the browser has to make connections. It has to understand everything about that text and turn it into AST that can be compiled to bytecode. But the browsers that run this don't do that all at once. They just do the high-level ones and the ones that are more likely to be run and create stubs for the rest of them. In comparison, WebAssembly, this doesn't happen. It's like a JPEG image. As soon as it's downloaded, it's parsed. So imagine you're on a page and you want to look at the photo. As soon as the photo is downloaded, you don't see a compiling indicator. The photo is immediately available. The same thing happens with WebAssembly, because as soon as it's downloaded, it's ready to be run. WebAssembly already comes into bytecode format, but the browsers have to convert your text to AST, then to bytecode to run it. So the step is much smaller. The second part is compiling and optimizing. So this part is very interesting, because back in the days, browsers just read JavaScript as text and just ran it, like whatever comes next. But right now we have something called JIT, just-in-time compilation. What it does is, the browser tries to run your code, and the first thing that happens, it compiles that and optimizes it and tries to guess what's going to happen next. So it's going to try to guess the types of all of your objects, all of your functions, what kind of inputs and outputs they produce, and compiles a version of that code that is fastest to run. But WebAssembly, in comparison, doesn't do any of this, because if you write it in a programming language that is actually a programming language, you're using types. And when you are using types, your compiler already knows about everything that happens in your code. No surprises is going to happen there, so there is no optimizing happening. So you download your code and it just compiles immediately because there is no compilation again, it's already bytecode, much closer to machine code. The next step is re-optimization, which is one of the most expensive parts in JavaScript. Let's say you have a loop. In that loop, you try to download some data from internet, and that data has some kind of wrong data type or different variables that gets injected into your loop. JavaScript compiler is like, oh shit, what's gonna happen now? So it's gonna throw away the already optimized code, start optimizing it again, and try to guess what's gonna happen after this. Or let's say, as a lot of JavaScripters do, they just inject a function right into the prototype chain. JavaScript compiler is like, I'm out of here, I'm just gonna go. But WebAssembly doesn't have this because you cannot insert anything in the middle of anything else. It's just there. It's a static typed code. So there is no re-optimization happening. Execution. Again, JavaScript is interesting because just-in-time compilation does a lot of optimizations to your code so it runs faster. So it is possible, in theory, to write your code in a way that JIT will like it and will run it fast and optimized. But the problem is not all browsers implement JIT in the same way. So Firefox and Chrome might like it, but Internet Explorer is like, I don't know what this is even, like, I'm just gonna wing it. So that's what's happening in execution in JavaScript. On the other hand, WebAssembly doesn't have that, it just immediately runs your code. The last step is garbage collection again, because JavaScript wants you to be happy and write however you like your code. It collects your garbage for you. So if you have a dangling variable that has no use anymore, if you have some data stored in memory that nobody uses it, garbage collector runs and cleans those up. So your memory doesn't get clogged. The problem with that is that garbage collection is a process that runs in the browser. In some browsers runs parallel, but in many browsers runs in the main thread. So in the middle of your nice game that is running 60 frames per second, garbage collection truck comes and like kind of smashes everything to the wall, and it's just chaos there. WebAssembly doesn't have garbage collection because you need to pick up your own garbage in the code already. As you know, in C and C++, you have to free up memory, take out garbage. Rust is more forgiving, it lets you get away with things and implements it for you, but anyway, it doesn't happen in WebAssembly. So, what programming languages compile to WebAssembly target? Before that, I need beer. On top of the list is my favorite, Rust, which is one of the most active programming languages that compiles to WebAssembly. It has a working group, which is a group of people who decide what to implement and when. It is one of the most feature-complete programming languages for WebAssembly. After that is C and C++, which are amazing. It has been compiling to WebAssembly for a long, long time, even before WebAssembly was a thing. Go is at the same place with Rust. They're competing, but you can even compile JavaScript to WebAssembly and run it in JavaScript. I mean, God knows why you would want to do that, but you can. There is a list of the programming languages there. Demo time. Hopefully this will not explode. Yes. All right. So I need to explain what this is. I'm going to run it first and then show you a bit of the code. For those of you who don't know and haven't been to computer science school like myself, this is Conway's Game of Life. You have a board with lots of cells in it, and you fill it randomly with dead or alive cells. So here, if they're divisible by 7, they're alive or dead, whatever. I cannot read so much. So anyway, it's filled randomly. And from there, you take the rules of the game into account. If a live cell is surrounded by less than 2 live cells, it dies of underpopulation. If it's surrounded by more than 3 live cells, it dies of overpopulation. If there is 2 or 3 live cells, it remains. If a dead cell is surrounded by 3 live cells, it becomes alive. which means it reproduces. And play. So this is a simulation of life, basically, of what happened on the planet, if you don't believe in anything else. But you can shoot stuff. Imagine these are like meteors from Mars that come and like blow life into us. So you can shoot stuff here, if I can get a free area. And you can pause it, you can modify it. Imagine you're God. Exactly, but not exactly. Yeah, so it started to run away. So this is mathematics, which is beyond me. I do not understand how those rocket ships work. I mean, somebody said if you put this on the page, it will become a rocket. Well, not rocket, that's a spaceship. This one is a rocket. But anyway, the core for this is written in WebAssembly, no, in Rust, but compiled to WebAssembly. And as you can see, the most important part of this is it's running 60 frames per second. If you run the similar things in JavaScript and run it in Angular or React or anything else, it's gonna clog. So it's not gonna be so happy about so many cells and so many calculations on the page. Maybe for 32 by 32 will be fine, but it's 64 by 64, you can expand it to the whole page. And it's gonna complain. JavaScript, the garbage truck, will gonna start like running in the middle, and then people are gonna be bashing into the walls drunk. So it's gonna be chaos. But this is running 60 frames per second. Well, let me shoot something at them because they're miserable. Yeah, all right. The UI for this is written in Angular. I'm sorry. But I tried to run it in make it in React, and time ran out. And it was running like 30 frames per second. That wasn't gonna make my point. So I'm gonna show you the code now if it works. So I need to come out of this. Where's my cursor? Yes. All right. Well, I don't have any presentation plugins, but you can just. All right. So this is the Rust code that is implemented. As you can see, it's in Rust and not JavaScript. So that's the most important. I'm not going to go through the details of what it does, but basically it implements a cell, and then implements a struct universe, and then implements the universe, which has the live neighbor count, which is an algorithm, does this. Tick, which is every revolution of this screen, which is running 60 times per second, and might be higher based on your graphic card. So let's say that Safari lets you run this on iPad Pro, which has a 120 Hertz display and has a good CPU. So this will probably be around 120 times per second. But anyway, it has the logic that I explained here, and there's other stuff attached to it. But anyway, this is the Rust code. And how you would use this is, if I can actually bring this. Where's my cursor? All right, so, what? No, right here. The SRC is there. You just run wasm pack build. It builds it for you. That's it. I mean, it uses cargo underneath, but the result is this. You have a PKG folder here. You have a wasm file. Then some JavaScript bindings that help you use it. But that's it. I published this to npm, and then here's my, again, sorry, Angular code. And here you just import universe and cell from ng-game of life, because we implemented those. And if you see, here I added a special tag, wasm bindgen, which is a helper tool that exports this from the Rust code. And they're here, universe and cell. And then memory is the most important part that I wanted to explain. But this is directly coming from the WASM file. If you see, like, the WASM file is called like _bg.wasm, and I'm importing memory from it. That's because WebAssembly and JavaScript have shared memory, and that's the most important part. Because let's say you want to do parallel multi-threading without WebAssembly. What you can do is you can run web workers in your page, and that's actually kind of multi-threaded because it creates a V8 instance for each web worker. But the problem is web workers and your main page are only connected through messaging to each other. They don't have a shared memory. But WASM and your JavaScript have shared memory. So the same memory that WASM is accessing, JavaScript can access as well. So the memory here is an array buffer. It's the place that WASM reads and writes to. The Rust code is reading and writing to. So for getting my cells, I'm getting a pointer, which is a numeric value. It's an index. And then I create a int8 array, which is a representation of my memory in JavaScript. And I directly get the cells right from the memory that Rust was accessing. So if this memory is a variable's value in your Rust code, it becomes immediately available in your JavaScript by directly accessing the memory. And this is the fastest way. Because imagine if you were stringifying this whole board as zeros and ones, and you would send it here, it would never run at this rate. But this way, the Rust code we call tick. Where is it? Yes. So we call tick, and what tick does again, calculates the next cell, and then changes its own variable, internal variable to next cells. And in JavaScript, we just directly read it from there. We don't need to get any data back from it. So that's why it's so fast, because you have a shared memory. And the cool part is, Chrome's V8 now supports multi-threading of WebAssembly. So if you actually have C or C++ or Rust, and you use the multi-threaded possibilities of that language, if you import it in Chrome and use it, it will actually spin up multiple V8 instances which have shared memory. JavaScript itself doesn't have that. So I guess the code for this is available, which I will show in the links. But that's it. That's the demo. Thankfully, it didn't explode. I stole most of the talk images from the second link, but these first two links are mostly about WebAssembly. Mozilla is doing a great job at explaining it and supporting it. Most of Firefox Quantum's rendering code is written in Rust. So Mozilla is investing heavily on Rust, which is why it's so popular now. And they're also doing really well with WebAssembly. They even made it possible before Chrome. Chrome was way behind. But anyway, the third link is the thing that you use with Rust code to add JavaScript glue to your code and export them from the file that you saw at the flag. The fourth link is the code that I just showed you. It's in a repository. You can run it yourself. You can try it. And the talks for this, this talk is available on the URL. And you can find me on social media everywhere with the same username, unlike my normal name has 2 L's. And thank you. So any questions about anything? Just
Thanks for the great talk. I got 2 questions if we have time. One of them is that you mentioned somewhere about the bundle size. You said there's something equivalent in JavaScript if it's like 0.5 megabyte size. It's probably around 30 kilobytes, so does it mean that I can rewrite React in WASM?
Yeah, that's the thing. They have rewritten React in WASM, but it's not so cool yet. Like it's not feature complete, because the problem is the browsers are not as good as integrating WASM code into DOM as JavaScript itself is. So yes, you can. But there are some libraries that look exactly like React, but they are completely in WASM.
Okay, my second question is, how would you advise people to get on running with probably Rust for WebAssembly? Is there any kind of resource for like, getting productive with WebAssembly?
Yeah, so I will tweet about this maybe. I will tweet a link. There is a book, online book that you can follow step by step, and it teaches you Rust and WebAssembly at the same time. And that's amazing because the first Hello World will kind of change your life and you want to go into the rest of it. Like there's a Hello World and you implement the whole application. But yes, there are really great Rust frameworks for doing UI libraries, etc. But one thing that I can say is maybe WebAssembly for now is not the best thing to write UI in completely. So handle the UI in React or Angular, but write the complex logic in WebAssembly, and that's where it shines. But UI for now is not that strong. That's why I didn't mention it, because I didn't want to badmouth it. So, any other questions? Finnish audience. All right, thank you very much. So I guess, yes. Oh, actually, we can turn this a bit down. Yeah.
Good.
When is the next one?
No, your turn.
Yeah. Okay.
Good job, buddy.
Thank you.
No, good tradition.
Thanks.
All good?
Test, test. Yeah, can you hear me well? Yes? Good. I'm going to give a couple of minutes, so if you have you want to drink something, you have time still. Is it normal that there is blinking
Sorry?
It's normal that it's blinking the script.
It should not.
Do you have any adapter for it?
Let's maybe take it out and on again, because last time you connected it was not like that.
Do you have any of these adapters?
We can use it. Probably there's a better way of doing it.
Shorter, yes.
See if it works.
Serve anything. It's a build tool. I like to think about it like a web compiler. It does not serve GraphQL or. When you run Gatsby build, you will see something like this. It takes from 20 seconds to 2 minutes, depending how big is your website. But this is Gatsby. It's a Node.js process, runs in your machine. You can run it in a server, Circle CI. But this is Gatsby. It's not a framework where you ask requests with GraphQL. So that's why I think about it as a web compiler. What is a compiler in the broad sense? It's something that takes something with high level language to something more low level. So think like you have some data in the input and your React application. You run it through Gatsby, and the compiler, what it produces is a bunch of files. You can see in the output, it will produce the index HTML, that is the front page, a bunch of JavaScript files. These are produced by Webpack, that is really good at code splitting by chunks. Some static files, images, CSS. So if you get out of this room, at least with this concept in the head, I think I have done my goal. The second concept I want to explain is that Gatsby is really fast. It's not a joke. I never have seen something so fast. It's not the traditional, I'm going to make a couple of optimizations in my website, and now it runs in 200 milliseconds. We're talking about 4 milliseconds load of websites, thanks for many techniques that I use under the hood. So it's really optimized output what Gatsby produces, and I think that's the attractiveness of this framework. Some people say, well, I know already other static generators like Jekyll, or like there's nothing new in Gatsby. But it is, because most of these static generators actually just generate HTML. And HTML, okay, yes, it's fast, but it can be even faster. If you, Gatsby uses certain techniques like prefetches and things that will feel even faster than HTML. Another confusing part for me was, okay, but it's React, but at the same time it's HTML. Of course, for people who are very used to work with server-side rendering, maybe this is normal. But I think for many people, they are not so used to think about React being server-side rendered. So the way I think about it is that this HTML, they are HTML, but at the same time they represent dry React components, and they get hydrated once that it hit the browser. React, the framework itself, offers this API that you can stringify and rehydrate the React. So this is very powerful in a way that you have a fully React application at the end. It gets delivered the same way that if you will do it with Create React App framework, for example. Okay, so I talk about GraphQL, but where is then in this picture the GraphQL? Again, the end user doesn't make GraphQL requests. Gatsby does not serve requests. To explain where sits GraphQL here, I will go a bit more in details about the build step. When it grabs the data from the sources, Gatsby collects some type of in-memory object here. And then when it renders the React application and executes the queries of GraphQL, the GraphQL queries hit against that data. So there is no API, it's no. I like to think of as GraphQL as the Morse code that you can implement in many ways. You can do this like this machine, or you can do with lights between boats to give signs. So GraphQL doesn't specify it. You have to implement it this way. GraphQL is just a specification written by Facebook, but you can implement it in many ways. And this is a very creative way of doing it, because still you have the expressiveness of GraphQL and you're familiar with it, but it's not used in the normal way. This is again the third concept that for me took a bit of time to get it right. So if users normally are very happy to get HTML just from your website, and Google also is really happy to see just HTML when it's crawling all the internet. But when you create a React application using Create React App, probably the most popular framework to start with React, what it generates is actually empty index HTML that the user downloads, and they say, okay, you need to grab these bundles. And then goes another second request and downloads the bundles. And then probably it's even a third request to grab some data. So all these trips of data back and forth is what it makes slow, and I think it brings a bit bad fame to React. Like, hey, it's better just HTML, it's faster. Why you're creating all these bundles? And so the power of Gatsby is that still you can write your normal React applications, but the delivery is just HTML. So it has the performance of a typical website, but still you or your front-end developers can write React. And Google will be really happy about it, because Google still can do all this for you and render the JavaScript text, but it will be not so slow. Another key concept is that you stop, once that you start working with Gatsby, you stop thinking about web development, or that you are coding something that is live all the time, that is serving requests, and you think more like, okay, I'm taking snapshots. Your editor or you change some article at the data, then you run Gatsby build and gets generated another snapshot. And those snapshots are made of HTML, so they can be uploaded anywhere. There is no database, there is no Node.js, there is no PHP, there is nothing, it's just a bunch of files. But the problem is that every time that you want to update it, you will have to generate a new snapshot. And this way of thinking it blows your mind a bit. But after a while, you get used to it, and it gets much better. So in conclusion, Gatsby is a web compiler, blazing fast, with GraphQL at build time, not at the end. And it takes the concept of create React up to a new level and think about it as snapshots. Now I will explain a bit more like why we like it to use it at Wonder. By the way, I didn't introduce myself. My name is David, and I work at Wonder, senior front-end developer. So at Wonder, we work a lot. Well, we like it for two reasons. First one is that performance is user experience. If you don't agree on this, if you think that it's okay to wait 5 seconds in your mobile phone to load a website, I think there's something wrong with you. And then the second reason is that we in Wonder work a lot with CMS, and especially Drupal. And once that you start to discover the power of Gatsby, then you start to see Drupal more like something like, okay, it's really cool for managing data and for editors to go in, log in, put all their content. But the front end is lacking, and the JavaScript land is where all the hotness is happening and all the performance, all the innovation is happening. So for us, has been a really good combination to work with, and also allow us to split the work on backend developer and front-end developer, and both they're happy. Because if you say to a front-end developer, okay, work with PHP templates or Twig, maybe they're not that excited about it. This is a couple of Gatsby sites we have built, more or less following this structure. Drupal is only for editors. They fill the data. That data gets consumed by Gatsby, produce the React web static site. And still we add a bit more interactive elements, maybe a search with our own Elasticsearch engine. We run Gatsby in Circle CI, so you don't need to do it in your local machine. It's more like with pull requests integrated, a bit more enterprise level. Maybe you're used to Gatsby. If you read it out there, you read more like, okay, I create my portfolio of 3 pages with Gatsby. But I think that is a bit misleading. Gatsby is much more powerful. And if you have really good structured content, it can produce very big websites, and the end user is not going to tell the difference of if it's static or not. Also, Drupal is really good at managing multiple languages, and that's something lacking in Gatsby. Maybe it's because Gatsby comes from USA, and USA just think, okay, there's only one language in the world. But I think you agree that the rest of the world has many other languages. So for me, Gatsby is setting new standards. I think sooner or later, the customers are going to be asking, hey, I want to be as fast as my competitor. Gatsby is making a new line on the sand saying, okay, this is the new way of delivering websites. If you know that logo, it comes from Lighthouse audit tools. It's really difficult to make Gatsby slow. You can do everything you want, but the output is always going to be compiled really performant. I imagine that in the future, Gatsby could take will be a bit like a standard way of delivering websites. So it can take a bit of the front end of PHP, Java, Ruby, and other backend frameworks, because almost all of them, they trust just on, okay, you can dump a bunch of variables in a template, and that's the output, but that's a bit limited if you think about what Gatsby can do. So, the more you work in a project, and the more complex it becomes, normally it affects the output. At the beginning, probably you are, okay, it's very simple, my website, and for the end user, downloads really fast, and then you keep adding features, and each time gets slower and slower, and then at the end, you say, how am I going to do this faster? And try to tweak it a bit, but there is no time or budget. So what Gatsby allows is that it doesn't matter how complex it is, then comes the compilation step, and Gatsby will produce always a really performant HTML. So now you can focus on the build time to do whatever you really need to do, because then later it will be compiled. So, for example, it doesn't matter if you spend 3 seconds making a request to artificial intelligence engine to get recommendations for this something. It doesn't matter, because that's a build time. Then later it gets compiled, and that is super performant. I think once that you get a taste of this compilation, then you start to think, like, this is the future. WebAssembly is another example, as Salar has explained. Like, once you get used to compile things, like, it doesn't have sense so much to keep running things on the browser or on demand. Of course, for some use cases, not everything, but I think it will be a new standard. And of course, something that you will enjoy a lot is that all this compilation treats as HTML, so there is nothing running. You don't have to worry about, hey, I'm going to get hacked, or there is a security update at 5 o'clock in the morning. The customer is now going to call you, hey, the website is down. So all these headaches disappear with Gatsby. Another thing we like from Gatsby is that it's not just a tool that one guy has done during the weekend. It's actually a company, and there is a lot of really good people working in it. I think that's becoming quite a pattern. Like, you can trust certain open source frameworks if you see that there's a company behind and they're putting resources, and these people are on the issue queue constantly. You fill an issue, and after some seconds you will, the same day you will get an answer. That's for sure. And this is now, but the more other, in the future it will come other possibilities to even improve the performance. Gatsby is always on the line trying to make it even faster. And other developers and people are already taking note of what Gatsby is doing and trying to offer it outside of Gatsby. Of course, all not is good in Gatsby. The first, more clear limitation is that once that it gets compiled, is all HTML, there is no authentication there. So Gatsby only has sense mainly for public sites where there is no login, or of course you always can say, well, I can, because then it's a React application, so you can add an extra step of login, but then it will be taken care by other framework, not by Gatsby. But Gatsby's strength is the public websites, anonymous users. There is not, will be quite difficult to add personalization to a Gatsby site. So in conclusion, Gatsby is a web compiler that lets you to have finally both things. Create React applications and that they are performant. And I don't know if you remember this movie, Apollo 13, I think it is. This Houston, we have a problem. And then you have 5 engineers, okay, they have these elements in the spaceship, how we can, so sometimes you feel like this with Gatsby, because it's not the normal workflow where you have all these resources and no limitations. You have, okay, you have this element, and it has to work only in the build time. Yeah. So it's quite fun if you like that type of creativeness to work with. Of course, some people get frustrated, like, wow, this is shit. I could have done this in 2 seconds with other framework, but you have to pay the price of the compilation. And several of our work colleagues already has got some t-shirts and things. If you get some pull requests merged into Gatsby, they will welcome to the community. And but those 2 things are, I think, the biggest complaints about Gatsby, and of course they know, so they are working really hard on nailing those 2 problems. With the previews, they are releasing just now some beta preview system, but it still is not, I think they are doing it first for Contentful, but not for Drupal. And for the other issue, they are working on some system that is called incremental builds. So you don't have to regenerate the whole site every time. It's more like it works with diffs. So those 2 things will improve a bit the user experience. Yeah. We're a bit in the early days of Gatsby, I think, so it cannot replace everything. Drupal offers so much and it's so flexible that it cannot replace it.
And I guess when you talk about that it compiles everything, it also minifies HTML and makes it really small.
Yeah, it does. Every single optimization you can think about it.
You should try to do my static web pages to see if it makes it even smaller.
Yeah, thank you.
Yes. So, if I understood correctly, is the Gatsby like where it shines is the like let's say some company website which is public, and the content doesn't change that often, or like?
Exactly. I think that's the key, that the content doesn't change so often. If it will be a newspaper front page, probably gets updated every 2 minutes, so maybe it doesn't have so much sense. But something that you can think, okay, this content doesn't change that often, maybe once every day or every week. So I think then is where it shines, as you say. Yeah.
So how it actually goes, like let's say that we have a website that updates once a week,
yeah.
And there's some content editor who is using the Drupal or whatever,
yeah.
And they change something in Drupal, like what happens then?
One of our developers have coded a module called build hooks, and that you can configure to, like when someone edit or save a piece of content, can call a hook, a webhook of some platform. There's many platforms nowadays that support something like this, Netlify, and those platforms, when they receive that webhook, reruns the Gatsby build command. So it's quite automated that you don't have to do it manually. They don't have to call you, hey, can you run that command for me? So, that's the solution for now. Yeah.
Thanks.
Related to that one, and also another question. So it's kind of like you said, Jack Yule or Hexo or any of these other ones that are out there.
Are they Jack?
Jack Yule. Is it like Jack Yule as well?
Yeah.
So?
I think. I don't have experience with jQuery, but I understood that it's more like, okay, you have Markdown and transpose to HTML. It's quite basic in a way like this. I think Gatsby said, I don't have any opinion on what you're bringing to me, what data. It can be Markdown, it can be API, it can be a GraphQL endpoint, it can be a Google Excel sheet, it can be a web scrapper, the point is that it's open to, okay, bring me whatever you want, and then you can code to create pages based on whatever you want. So it's much more flexible, I think.
My next question is related to the previous question, in the sense that if you have an automatic build, for example, how do you take care of, for example, cached pages or things like that that are already on the client side?
We haven't faced any problem like that. I think somehow when you replace the HTML with a new snapshot, we haven't found any problem with the user browser caching the old version. Also, I haven't mentioned that Gatsby deliver a PWA type of minimal framework with service worker manifest, so it can work as an offline app in a way. So that's something also interesting. And maybe there is a bit more difficult to invalidate caching, but that's an interesting topic. Yeah, I cannot answer from the top of my head. Yeah. Question?
Well, I could start by just adding a little bit to the previous answer. So basically, if you have the static assets and you just set no cache headers to all the index.html files, so all of your HTML files have no cache headers. That way, they won't be cached by the browser, by the CDN, or any other caching layer, and you're linking from there to all of the assets that have unique file names, and that way, whenever you deploy a new version,
sure,
the index.html points to the new assets.
Thank you.
Then, yeah, a really, really great talk, and good job with that. I hadn't heard before about the incremental builds, so that's a really interesting feature. I kind of wanted also to add just that Gatsby is a great tool for what you said, for these kind of sites with a lot of static content. I'd also like to kind of say that we are, for example, now building a full web store with it. So whatever you could do in a React single page app, you could do in a Gatsby context as well. So nothing prevents you from
yeah, so you're doing one of these. Like, okay, it's static, but we need some dynamic parts for the e-commerce part. No? So trying to figure out.
Yeah, and maybe one question related to the content editing experience. So we've kind of had sometimes with the static site generators to discuss this kind of new approach to building these sites with the content editor, since they're used to the CMS just instantly showing the results when they edit the page. And do you have any kind of neat tricks to how to deal with that and explain to them this kind of new workflow of building sites for seeing the results?
So far we have just convinced them like it's worth the price that you pay by not having instant previews, but the final output is very optimized for the user. And also they are editing content in Drupal. So Drupal, you can save it and then you see the final, you see the content saved, but it's not styled. So they can see if, for example, check that everything is fine, but they're not going to have the final version. But it's good for them because you don't know where it's going to end up, that content. You don't know if they're going to end up in a tiny mobile screen, it's going to end up in a super huge screen, a TV. So I think it's good that they check that the text is correct, but then the final version. There is also something called Sanity. It's a SaaS version of a CMS that you pay and you can put there your content. And they have worked with an integration, Sanity and Gatsby, where you have live previews, instant previews. So if they have managed to do it, I'm sure that sooner or later other people will, other companies and products will start to produce instant previews. Okay, Georgie is going to go after me after this break, and he's going to make a demo.
All the levels, yes. Yeah, absolutely. We're more than happy to do it. Yeah, definitely, no problem.
Oh yeah,
here. No, don't.
Mute.
Hello everyone. Do you want to go back to your seat perhaps so you can start? Alright. Does this work?
It's a really stupid project. Oh, that's a lot. Thank you.
All right, so I guess we can start with the next Gatsby session for today. So, hello everybody. I would like to talk to you today about the Jamstack, and in particular achieving that with Gatsby and Netlify. Excuse me. My name is Georgi Yanev. I build things on the web, and I think that performance matters. I work as a web developer at F-Secure. You can find me as @JumpALaraha on Twitter and GitHub, and I blog at gyanev.com/blog, and I also fly FPV drones. So we're gonna quickly dive into the Jamstack and see what that's about, and then we're gonna check Netlify, and finally we're gonna dive into Gatsby for a deeper look. But before we begin, how many people have heard about the Jamstack before? So 7, 10 people, okay. What about Netlify? Have you used it? 10, 15 people? What about Gatsby? Nice, like 20 people.
Nobody listened to the previous one.
So, what is the Jamstack? If you go to jamstack.org, they define it as JavaScript APIs and markup. Quite straightforward, nothing groundbreaking or fundamentally new. When they talk about the JavaScript part of the Jamstack, they talk about JavaScript running entirely on the client, and it could be any flavor, any framework, or even vanilla JavaScript, unopinionated. The API part talks about reusable APIs, whether first party or third party, just leverage external services. The M stands for markup. Most of the time that's pre-built markup at deploy time using Gatsby, or other site generators for content sites, or a build tool for a web app. Some examples they give, this is again from jamstack.org/examples, and they highlight these sites. Maybe the interesting thing here is that you could approach and create a Jamstack in many different ways, again, regardless of your choice of APIs and technologies. This is the part that I like about the Jamstack and the 4 core ideas. Better performance, that's achieved by deploying static assets from CDN edges. Higher security, you reduce your overall attack surface, and you don't really maintain servers, that's good. Cheaper, easier scaling. It's very easy to scale up a Jamstack site because it's just static assets, and a better developer experience, mainly stemming from the fact that we don't have to support many different, like plenty of other infrastructure, basically. But what the Jamstack is not, it's not a silver bullet. We've already had like a nice discussion tonight. People have like very good questions. It does not answer all your problems. It's not the answer to all your issues. So consider the trade-offs. Engineering is about making the right trade-offs for your project. So choose the right approach for you. Actually, recently, Jason Miller and Adios Mani from the Google Chrome team put together an article that is definitely worth reading. It's a comparison of different rendering strategies. They have this image in that article, which we're not going to go into too much detail, but in a nutshell, of course, compares different server rendering versus more client-side rendering approaches. And this is where we're going to be thriving now. YouTube video Jamstack on the Google Developer YouTube channel. Check it out if you want to learn more about the Jamstack. Sorry about that. Which brings us to Netlify. Netlify has been making circles on Twitter, at least, and many developers are kind of in love with Netlify, and there is a good reason for that. What it is it's a hosting platform for your project, but it's been winning people over mainly with developer experience. It's really easy to get up and running with Netlify, quite trivial to get started. Their free tier is pretty awesome. You're probably gonna go quite far before you need to go to the paid tier in terms of bandwidth. They do provide an application delivery network, is what they call it, but it's essentially a CDN for your static sites and for apps. Continuous deployment is also something that is super easy to set up with Netlify. You just connect it to a GitHub repository, and by pushing to master, your site gets redeployed, which is quite useful. SSL certificates you get also with Netlify using the open source Let's Encrypt software. You can set up custom domains quite easily. You do receive a feature for automatic pull request previews, which is quite cool. Whenever somebody submits a pull request against your master branch, you could actually have like a live preview of that pull request. Additionally, they offer you Netlify functions, which is like simplified AWS lambdas. Netlify identity for dealing with authentication in one way. Netlify forms for bringing in form data by just using a data attribute, and so on. So how hard is it to deploy a site on Netlify? On the left-hand side, we have Netlify UI, and on the right-hand side, we're just going to create a super simple HTML page. Then we're just going to drag and drop the project, and that's pretty much it. We're live with HTTPS or SSL certificate enabled. Unless your video dies. Okay, that goes green again. But the real power of Netlify comes from deploying from a repository. You could connect it to GitHub, GitLab, Bitbucket, and just deploy from any branch with a build command. Which brings us to Gatsby. We already heard a little bit about Gatsby. The static site generator description doesn't really describe it clear enough. I do like David's web compiler description. I think it's quite good. In addition, the key thing here, of course, to understand is the blazing fast side of things and the fact that Gatsby does rehydrate to React. So in production, you will have a React app. It's not necessarily just static apps. Then for people just starting out, many times you don't want to set up all the tooling for yourself. That's why I guess Create React App, among other projects, are so popular. Gatsby does that also for you. It comes with Webpack, Babel, ESLint, Prettier, pre-configured. Gatsby is all about bringing your own data. That's the other, as we heard earlier, key point here. bring in your own data in any shape or form. It's deployable anywhere because it's just static assets at the end, HTML, JavaScript, and CSS. It's trivial to set up progressive web apps. It's a matter of including 2 plugins and then deploying that. The dev experience is pretty solid. There is a rich ecosystem of plugins, startups, starters, not startups. And there is an amazing community behind it. In fact, I might have even gone to say that a Gatsby site running off a toaster at CDN Edge would get a Lighthouse score of at least 70. But seriously, how fast is Gatsby? This is the default starter. It comes with Lighthouse audit scores of performance, accessibility, best practices in SEO of 100. And I also want to stress this point that performance does matter. A couple of days ago or last week was the web's 30th birthday, so let's build like quality experiences for the web. But it's about your users and about your business, and performance and speed and user satisfaction translate to money many times. There are also SEO benefits as of last year's July for performing and fast loading sites. And users are impatient. People don't like waiting around, and that leads to increased bounce rates. Also, let's consider the next 1 billion users coming to the web, because they are coming, and they're coming from places where bandwidth could be expensive or connections are flaky. So what does Gatsby do to help? It does a lot. The way it manages your assets, the way it prefetches particular assets, even going as far as prefetching links that you hover over for the next route. But here in particular, let's take a look at what it does with the Gatsby image component. It's a highly optimized lazy loading component. It doesn't come with the core of Gatsby. It's a plugin. You can use it or not use it if you don't want to do that. But images are one of the lowest hanging fruit for many people out there, and that's primarily because it could be a big portion of your total site bandwidth. So doing those right could be a good place to start. Additionally, Gatsby image would serve like conditionally WebP to browsers that support it, which are becoming more and more browsers that support WebP, also with the latest changes with Edge. Another thing that Gatsby could be cool if you would like to try it out and has been praised for is that it's a very easy way to try out React and GraphQL if you would like to give it a shot and you don't have much previous experience. And because it's just React under the hood, you could use any React module with Gatsby. So this is a graphic that I borrowed from gatsbyjs.org. And the interesting maybe part here is the breakdown is quite simple, and at a high level it really, I think, explains quite simply what it's all about. So we have data sources at the top. We could bring in data from headless CMSs, like Contentful, Sanity, as mentioned earlier, Graph CMS, I think, and others. You could also use Markdown to build pages. You could use regular Markdown, or you could use MDX and use React components in Markdown, which is like really cool, and it's coming. You could also use other data. You could use YAML files, JSON, Excel sheets, what have you. The interesting part is the build process in the middle. So Gatsby takes these things in and creates GraphQL types out of those for you. You could then query that data by those types. You create your site with HTML, CSS, and JavaScript, React, and then using the data from GraphQL, you build that, and then you deploy it to any static host, Netlify, AWS, S3, or whatever. Cool, so how do we get started? Well, the easiest way is you go to your terminal and you just run npx gatsby new my site, and you're off to the races. Additionally, you could also just give it a shot in codesandbox.io. They have a server template for Gatsby, so you could try that out and This was an embedded code sandbox, but I'm sorry, not today. Finally, many Gatsby starters in GitHub have a deploy to Netlify button, so just clicking that is gonna set up a Netlify project for you. But next, let's dive a little bit deeper into data sources. I kind of covered most of these, at least the ones in terms of fetching content from like headless CMSs and local files to your file system. But you could also use Stripe for building e-commerce sites. You could use Firebase, among others. So let's try GraphQL. That's not gonna work.
There is internet if you want to connect.
I also should have. Let me see, so I don't waste everybody's time. Okay. Gatsby opens up a Webpack server at localhost port 8000, but at the same time, it also opens up a graphical instance at localhost 8000/___ GraphQL, and that's what we're looking right now. That's kind of cool because it allows you to easily prototype how you would actually work and fetch data in using GraphQL and Gatsby. So because we had those JSON files set up, and we've included a few plugins, which I'm not going over, but it's part of the setup, that enables us to query against those JSON files. They are exposed. There is a convention, so it's not happening randomly. Gatsby documentation covers it very nicely. But in a nutshell, in our particular example, we're looking at this node here. All pages JSON because of the file structure. In here, we're gonna go into edges, node to get specific data. And the cool thing about graphical, actually, can you even see that? Yeah. Sorry about that. Sorry about that. Control space is your friend. You get auto completion, so you could query exactly those same fields. Get body as well. Finally, when you run your query, you're gonna get some data on the right. The cool thing about this is that you can prototype the queries in such a way so that you figure out what you need for your components, and you could literally copy-paste those queries from here back into your source, into your codebase for your query. And the other cool thing is that this is the data the way that it would look. Gatsby will expose to you a data prop that you can access on your components, and then you drill into that following the path. Next, a couple of words about plugins. So currently they have up to 700 something plugins. People are building plugins for all sorts of small chunks of reusable functionality. The important part is that you could, of course, utilize those. They do generally break down into source plugins, which deal with fetching or bringing in data, and transformer plugins, which massage data and change it into something else. And in addition, one cool feature is the fact that you are not limited only to the public plugins. You could also build your own private plugins. If you have an enterprise use case where you need to create your own plugin to fetch from a particular API, that could be helpful. If you're lazy to bootstrap your project with plugins, of course, you could head on over to the starters page and then just pick any of the, I don't know how many, there are like 100 and something starters. They are grouped by use case, and they are grouped by stack many times. So if you have very specific requirements, what CSS and JS styling solution you want, or whatever, you could pick a starter based on that. It's good for starting quickly with projects. Also check out the showcase, or why not also submit your own projects if you build something cool there. But what can you build with Gatsby? You could build simple sites, like you could build blogs. Again, 95 out of 100, even though the site has plenty of images. Documentation sites with live code playgrounds and still doing pretty okay. Some of the things I've built, one of those projects is fpvtips.com. It's a site about people who fly FPV drones to share the locations they fly with each other, alongside with photos and videos. We're just using, in this case, Contentful to fetch data from. It's hosted on Netlify, built with Gatsby, uses the Google Maps API, the Open Weather Map, and Markdown and JSON for the pages. The interesting thing here is, and the reason I'm sharing this is mainly because it's really cool to achieve a score of 80 without trying. I did not try. I didn't do anything for the performance of this site, so pretty good starting point for many projects. Also, my blog is built with that. Here I tried a little bit. I also have less APIs that I'm using. But again, the stack could be a Gatsby, Netlify, Markdown, styled components here. You could also build bigger things. In this particular case, this site is somewhere north of 400 or 500 pages. Nothing super huge, but not also one of the smallest. And it's very image intensive as well. So again, Gatsby image here helped a lot. We reach a 97 out of 100 score, pulls all of the data from Contentful, and hosts it on Netlify. And all of these projects are open source, so you can check them out at github.com/jumblarher. Finally, if we have time for a quick demo on what deploying a Gatsby site looks like. No. I'm just going to run npm x Gatsby new my site, and this is going to pull up the default starter for Gatsby and install a bunch of packages. While we wait for that, we can set up a new GitHub repository. Sure. Cool. I didn't do anything, I promise. Maybe I can. It's so fast. The screen refresh rate doesn't support it. Okay, so that's already here. So we're gonna refresh the GitHub repository. Oh no, I done goofed. Anyway, let's see if that works. We're now in the Netlify UI, so we're gonna create a new site from Git. Hub. That's the one. And now Netlify basically is going to detect my settings. In this case, it actually doesn't detect things nicely because I have another root folder, or like a folder at the root. Normally it would pre-fill all the build commands for me. In this case, we're gonna do this build command. Normally you don't even have to do that manual configuration. You just click a couple of times and you have your site. But that's it. And the cool thing about this is that I didn't have to do a whole lot to get, get up and running with a really nicely set up project. From now on, whenever and do contribute to Gatsby and score some sweet swag. The community is very helpful, so they will appreciate your contribution. In conclusion, I would just leave you with a couple of points, just that performance does matter, so let's build cool things on the web and good experiences. And then that building things with Gatsby and Netlify is fun and actually very productive. So go build something. Thank you.
Questions?
Oh, I do have a question.